Once again, a very warm welcome to all of you, my dear students. Now, here I am going to begin the reasonable facts related to the fourth chapter. So, here you have to understand the questions clearly, and the parts that I had discussed previously should be recalled. As a result, you can give your answer in your one. Reasonable question means that is the understanding type of question. That's why you have to understand something, and on the basis of that you have to give the correct answer. So you have to practice more. If you practice more, then you can do better. Otherwise, not. So try to understand. Yesterday we talked about the acceleration due to gravity on the of the freely falling body on the different surfaces. So acceleration due to gravity does not depend on the mass of the object, but acceleration due to gravity increase or decrease due to the effect of air resistance. That air resistance causes the increment and decrement of acceleration due to gravity. So what we can conclude is conclusion of Quine and feather experiment. Today I am going for the conclusion of Quine and feather experiment theoretically, just a lecture method, by the lecture method, and next time I will give you the idea with the help of the figure. Listen to me carefully. For the Quine and feather experiment, we need some of the apparatus, some of the materials. They are feather, coin, a long tube, and vacuum pump. Yes? So, a long tube is taken having its both end closed. In the tube, the coin and feather is kept on the bottom. When the tube is kept inverted, then the coin and feather fall. If there is presence of air resistance in the tube, then which one falls faster? When the tube is inverted, either coin or feather reaches the bottom faster. It is obviously the coin, isn't it? But when the air is completely withdrawn, removed by using the vacuum pump, then there is no effect of air resistance, and again the tube is inverted. Then at that condition, coin and feather reaches the bottom at the same time. The coin and feather reach at the bottom at the same time. Yes? So that is when there is presence of air resistance, acceleration of the falling body is different because of the presence of air resistance. But when the air is withdrawn by using the vacuum pump, then there is no effect of air resistance, and both coin and feather fall with same acceleration. So that conclusion, I will explain that next time with the help of the figure. Yeah. So we have to do that. But here I will write the conclusion of coin and feather experiment. What is the conclusion of coin and feather experiment? Acceleration produced on a freely falling body does not depend on the mass of object. Acceleration produced on a freely falling body. Freely falling body means what? That is, there is no air resistance. You have to remember. Acceleration produced on a freely falling body does not depend on the mass of the object. That means what you have to conclude is either the mass is very big or very small, the acceleration of all the object is same. But acceleration increase or decrease because of the effect of air resistance that I had already discussed with the help of the folded piece of paper and unfolded one. Yeah. So I am going for other reasons too, and these are also very important. I had provided some of the questions related to conclusion of coin and feather experiment. I am going to omit this. Do you know by how many times the mass of Jupiter is bigger than that of the Earth? The mass of Jupiter is about 319 times bigger than that of the Earth. However, its acceleration due to gravity is only 2.5 times more than that of the Earth. That is, the acceleration due to gravity of the Earth is about 10 meters per second square, and that of Jupiter is approximately 25 meters per second square. That means only 2.5. Even the mass is very bigger, but acceleration due to gravity is only 2.5 times than that of the Earth. What is the reason? The question I am going to discuss. I will say the answer. Remember that. As I say the answer, you have to be ready for writing the answer yourself. Okay? Do not copy. Try to do yourself. Even the mass of Jupiter is 319 times more than that of the Earth, but its acceleration due to gravity is only 2.5 times than that of Earth. Why? Once again I repeat, even the mass of Jupiter is 319 times more than that of the Earth, but its acceleration due to gravity is only 2.5 times than that of the Earth. Why? I want to make the question clear to you. We had already discussed the mass of the Earth is 6 times bigger than that of the Moon, but its acceleration due to gravity is also 6 times more than that of the Moon. But in the case of Jupiter, why it is not possible? Why it is not possible? You know that acceleration due to gravity depends on mass of the heavenly body and radius of the heavenly body. We had proved the formula. Acceleration due to gravity is inversely proportional to square of radius, isn't it? That means the bigger the radius, the less will be the acceleration due to gravity, and vice versa. Do you understand that? So it is the factor, it is the main factor that causes the value of G of Jupiter is only 2.5 times than that of the Earth. Now how to write, how to express the answer, how to write the answer, let me discuss about it. But remember, you have to do this question yourself. Are you ready, students? I hope you are ready. The mass of the Jupiter is 319 times more than that of the Earth. But radius is also too huge. Its radius is also too huge. That means about 11 times. Its radius is also too huge. As a result, the value of acceleration due to gravity of Jupiter is only 2.5 times more than that of the Earth, as g is inversely proportional to square of radius. Once again listen. The mass of Jupiter is 319 times than that of the Earth. Due to this reason, the radius of the Jupiter is also too huge than that of the Earth in the comparison of radius of the Earth. As a result, the value of acceleration due to gravity of Jupiter is only 2.5 times more, because acceleration due to gravity is inversely proportional to square of radius. Understood? That is, the value of g is only 2.5 times more because its radius is very huge, that is very long. Yeah, so you have to remember the similar question. An object is taken from the surface of the earth to the moon. Remember, an object is taken from the surface of the earth to the moon. Yeah. Will the weight of that object increase or decrease? If we take the object from the surface of the earth to the moon, then the object will have more weight or less weight on the surface of the moon. Obviously, the weight of the object decreases on the surface of the moon. Do you know why? Because the value of acceleration due to gravity of the moon is only 6 times less than that of the earth, and the weight of the object is decreased as W equal to mg. You know that weight is directly proportional to acceleration due to gravity. So how to answer? When an object is taken from the surface of the earth to the moon, its weight decreases. Its weight decreases because the value of acceleration due to gravity, is about 6 times less than that of the earth. So the weight of the object is reduced by 6 times as W equal to mg. When an object is taken from the surface of the earth to the moon, to the surface of moon, then what happens to the weight of the object? Weight of that object, and why? An object is taken from the surface of the earth to the surface of the moon, then what happens to the weight of the object and why? That what happens means, will the weight of the object be increased or decreased? The weight of the object obviously decreased by 6 times because the acceleration due to gravity of the moon is about 6 times less than that of the earth. So the weight of the object is also decreased by 6 times, as weight is equal to mg, W equal to mg. Okay, I think you got the answer of these questions. Similar reasonable questions I am going to solve for you, but one answer I will provide, and that is the guideline for you, and with the help of that answer you have to try to write the answer. Are you clear, students? I hope you understand. Where on the surface of the earth weight of an object is more, either on the pole or equator? Why? I am going to provide the answer for this. You know that? Where on the surface of the earth means you have to remember that is either pole or equator. Do you understand? Either pole or equator. So, here I like to make you clear with the help of the figure. Yeah. I want all the students, please turn on your video, okay? Our earth, you know that our earth is not a is not a perfect sphere. It is not completely round. The polar region of the earth is somehow flattened, and equatorial region is bulged, or we can say expanded. Yeah, that's why it makes the radius of the equatorial radius more than that of the polar radius. This is pole and this is equator. Better to use that particular point. Our earth is not a perfect sphere. As a result, the polar radius is smaller than equatorial radius. Polar radius is lesser than the equatorial radius. And you must remember, from this relation, acceleration due to gravity is inversely proportional to square of radius. Isn't it? So, the place where the radius or distance is less, the value of g is more. Where the value of g is more? The value of g is more on the pole. Yesterday, we had written the value of g on the pole, that is 9.83, yes? And value of g is less. This clarifies that as the radius is bigger, the value of g is lesser, and vice versa. So the radius is less on the pole, so the value of g is more on the pole. Where the value of g is more, the weight is obviously more, from W equal to mg. Do you understand? So I will provide how to write the answer in simple way, and you can write the answer with the help of this guideline. Okay? Okay. Our earth is not a perfect sphere. So, the polar radius is less than the equatorial radius. Radius. Due to this reason, the value of G is more on the pole, as G is inversely proportional to square of radius. Hence, the weight of object is more on the pole, as W equal to mg. In the same way, you have to write the answer for this type of questions. First of all, copy this down fast, and I will provide the number of questions having the similar type of answers. You keep on copying. I will say some of the questions. In which part of Nepal the weight of an object is more? Part means what? We basically understand the Tarai region and the hilly region or mountainous region, isn't it? So, can you tell me where the weight of an object is more in Nepal? Either in Tarai region or in the hilly region. You know that Tarai region is situated at low height, isn't it? Low height. That means the distance is less, altitude is less. Don't forget, the distance is always taken from the center of the earth. That's why Tarai is situated at less height than the hilly region. So the value of G is more on Tarai region. Yeah, G is inversely proportional to square of distance. In place of radius, you have to write square of distance or height. So the weight of the object will be more on Tarai region, as W equal to mg. You take the hint from here and try to write. Bundle of questions can be made to give the similar answer. I will discuss about another question also. Where the weight of an object is more, either on the bottom of the hill or top of the hill. It is obviously the weight of an object is more on the bottom of the hill than on the top of the hill, because the bottom of the hill is at less height than on the top of the hill. As the height is less, the value of G is more on the bottom, as G is inversely proportional to square of radius. So the weight of the object is more on the bottom of the hill, as W equal to mg. In the similar way, where the weight of the object is more, either in Kathmandu or in Chittagong. Another question. The weight of the object is more in Chittagong. You know, Chittagong is situated at less height, isn't it? So, those different types of questions you have to solve. Okay? So, I am going to provide those questions. That is the work for you. The previous one also. If you have copied, then I am going to omit this. Weight of an object is more in Tarai than in the hilly regions. Hilly regions. Why? One of the question. Having the similar sort of answers. Number 2, weight of an object is more on the bottom of wheel than on the top of it. Why? Number 3, weight of an object is more in Bharatpur than in Kathmandu, KTM. Why? Number 4th one, you try to solve these answers. Try to solve these answers. Now here last question for you. A stone is dropped on the pole and equator of the earth. Where